Hey everyone! Today we're going to look at the last two conic sections, which are the ellipses and hyperbolas. So first, the ellipses. In the diagram, you can see there are two different standard forms of an equation for an ellipse. In the first picture, the equation is x minus h squared divided by a squared plus y minus k squared divided by b squared equals 1. In the second picture, the equation is slightly different. This time it's x minus h squared over b squared plus y minus k squared over a squared equals 1. The a is always going to be the larger number. So when the larger number squared is under x, so when a is under x, that means the ellipse is going to be longest on the x-axis. Right? But in the second equation, notice that a squared is under the y squared. So when the largest number is underneath y, that means the ellipse is going to be longest on the y-axis. Okay. In each of the ellipses, you have the center, right? And then the vertices are always going to be on the longest axis. So in the first picture, you will notice there's vertex 1 and there's vertex 2. It's longest on the x-axis, so the vertices are on the x-axis. The longest axis is always called the major axis. And so then the shorter, squattier part of the ellipse is called the minor axis. Okay, now the distance from the center to a vertex is a units. The distance from the center up to the point on the minor axis, so the shorter part, that is b units. Now, there's a focus inside an ellipse. Actually, there's two of them. They are each on the major axis, and they're just in from the vertex a little bit. So you can see here's focus 1, and there's focus 2. The distance from the center out to each focus is c units, right? So the distance from the center to each focus is c units long. Now there's a relationship for c based off of a relationship with a and b. C squared equals a squared minus b squared. All right, so it's very similar to the Pythagorean theorem, but it's a little bit different. You have to subtract a squared minus b squared, and that gives you c squared. Okay, now the focus on an ellipse, there is a really good use and example of this in the United States Capitol building. One of the rooms inside was a former Senate room. Now it's called the Whispering Room. Within this room, it is in the shape of an ellipse. There are two little metal plates on the floor in this room, and those metal plates are in the exact position of the focus. Well, if I was standing on one plate on one focus, and you were standing on the other plate, the other focus, and let's say our backs were to each other. Now, this is pretty far way apart, at least 25 feet apart. If we were with our backs to each other, but I'm on one focus and you're on the other, I could actually whisper and just barely speak anything, but you would be able to clearly hear what I was saying where you're standing on the opposite side of the room. There's an example of this on YouTube, so if you want, you can go research it. In YouTube, type in whispering room U.S. Capitol, and it may be whispering gallery or something like that. But there's a tour guide that is a lady that's older, that she is this tour guide, and she demonstrates this principle. So it's kind of fun to watch. I suggest you go look for it. All right, so on the second picture, where the ellipse is longest on the y-axis, you can see now the vertices are on the y going vertical, and then the focus is just inside from each of those vertices. Has the same principles. The distance from the center to a vertex is a units. The center out to the point on the ellipse that represents the minor axis, that's b units. And the distance from the center to the focus is c. And again, c squared equals a squared minus b squared. So let's look at our first example. On our first example, we need to graph the ellipse x squared over 16 plus y squared over 36 equals 1. Okay, first thing we pick out is the center. The center is hk, x minus h squared plus y minus k squared. So in this case, when it's just x squared over 16 plus y squared over 36, the h is 0 and the k is 0. So the center of this ellipse is 0, 0. Now, as we look at the denominators, the larger number is always going to be a squared. So in this case, a squared is 36, b squared is 16. Since the a squared, the larger number, is underneath y, that means y is the major axis. So this ellipse is going to be longest on the y-axis. Now, if a squared is 36, that means a is 6. Since b squared is 16, that means b is 4. To get the total length of the major axis, well, since the center to the vertex is a units, then you're going a units to the first vertex, but you're also going a units to the other vertex. So to get the length of the major axis, it is 2 times a. Well, in this case, 2 times 6 would give us 12. So the length of the major axis is 12 units long. The minor axis, the distance from the center out to the shorter part of the ellipse, is b, and since you're going in both directions, then the length of the minor axis is 2 times b. Well, since b is 4, 2 times 4 gives us 8. As we look at the graph, we start with the center, and this center is at 0, 0. It has to be longest on the y-axis, so from the center, we're going to go up a units and down a units. Well, a was 6, so we go up 6 and down 6. The shorter axis is the minor, so from the center we go left and right b units, which was 4. So to the left 4 units and to the right 4 units. That's enough to draw the ellipse. So now we curve it and we get the ellipse. Now the focus. We do need to put the focal points on here. So to get the focus, c squared equals a squared minus b squared. So c squared equals 36 minus 16. C squared then equals 20. Square root that. So c equals square root of 20, which is 2 square root of 5. Now, to graph it, we can plug it in the calculator and get a decimal equivalent. So that is approximately, it's close to 4.5. So then from the center of the ellipse, remember you have one vertex and the second vertex. They're always on the major axis. The focus is just in from the vertex on the major axis. So from the center, we're going to go up 4.5 units. Puts it about right there. So focus 1. And then we go down 4.5 units. Focus 2. All right, that's it for that ellipse. On number 2, we're going to graph x minus 3 squared over 49 plus y minus 5 squared over 9 equals 1. Now notice on every equation of an ellipse, the equation always equals 1. The center is always HK, so there's H and there's K. Remember, I always take the opposites, it's counterintuitive. So the center is 3, 5. So on the graph, we're going to start with the center at 3, 5. So over 3, up 5. Now, look to see which number in the denominator is the biggest. That's 49, so that's a squared. And if a squared is 49, that means the other number, b squared, is 9. The largest number this time is underneath x. So that means x is the major axis. So this ellipse will be longest horizontally. Since a squared is 49, that means a equals 7. So the length of the major axis is 2 times 7, which is 14. B squared equals 9. Therefore, b equals 3. So the length of the minor axis is 2 times 3, which is 6. So on our graph, from the center, because the major axis is x, we're going to go to the left 7 units and to the right 7 units. So that puts us at -4. And then going to the right 7 units puts us at 10. The value of b is 3. So from the center, we're going to go up 3. And down 3. Make it a curve. And then last, we want the focus. C squared equals 49 minus 9. So c squared equals 40. Square root that. Simplify, so that's 2 square root 10. Decimal equivalent is approximately 6.3. You have your vertices, V1 and V2. The focus will be just inside the vertices. So from the center, we're going to go to the left 6.3 and the right 6.3. So focus 1 and focus 2. All right, now we're going to talk about hyperbolas. Hyperbolas is in section 7.3. The picture shown is the picture of a hyperbola. Okay, the portion of the hyperbola that is actually part of the hyperbola is this portion and a symmetrical portion below. Okay, a hyperbola, it still has a center, but no part of the graph actually goes through the center. Okay, the distance from the center to the vertex is a units. The distance from the center out in the opposite direction from where the vertices are is B, and the distance from the center to the focus is C units. This time, instead of having a major axis and a minor axis, we have what's called the transverse axis and the conjugate axis. The transverse axis is the axis that connects the vertices. So this is the axis that each vertex is on. It has a length of 2a. So that's kind of similar to the major axis from the ellipse. The other axis is the conjugate axis. So this is kind of similar to the minor axis of the ellipse. It is perpendicular to the transverse axis, passes through the center, just like the transverse axis passes through the center, and has a length of 2b. We have two different equations that are standard forms for a hyperbola. We have, first, x minus h squared divided by a squared minus y minus k squared divided by b squared equals 1. This time, whichever variable comes first in the numerator, so in this case, x comes first in that equation, that means the hyperbola opens left and right. So the vertices are on horizontal. In the second equation, y comes first. So we have y minus k squared over a squared minus x minus h squared over b squared equals 1. So when y comes first, then the vertices of the hyperbola are vertical. And so this time it opens up and down. So you're looking for whatever is first in the equation, whether it's x or y. If it's x, opens left, right. If it's y that comes first, it opens up, down. With hyperbolas, there is also a relationship between A, B, and C, but it is slightly different than the relationship between A, B, and C for an ellipse. When it's a hyperbola, it is exactly the same as the Pythagorean theorem. C squared equals A squared plus B squared. All right, so let's look at example 1. We're going to graph the hyperbola given by y squared over 9 minus x squared over 25 equals 1. First, the center of the hyperbola. Center is always hk. H is always the value with x. K is always the value with y. In this case, there's nothing there, so that means the center is 0, 0. For this one, we always look to see which variable, x or y, comes first in the equation. This time, y squared comes first. That tells us this hyperbola opens up and down. A squared always comes first. B squared always comes second. So a squared is 9. Therefore, a equals 3. B squared is 25, therefore B equals 5. So when we graph, we start with our center at 0, 0. Then we go with the vertices. The vertices always deal with A, always. Because this opens up and down, then that means my vertices are going to be going vertical. So from the center, I'm going to go A units up and down. A is 3, so I go up 3 and down 3. The conjugate axis is always the opposite, and so that's B. So then in this case, I'm going to go B units left and right. So that's 5 units left and 5 units right. Now here's where graphing a hyperbola is a little bit different. What we need to do now is we're going to draw a box, a rectangle that connects all 4 of those points for the vertices, and I'm going to label the vertices V1 and V2, and the points on the conjugate axis. Now, it's not straight lines in between those points, but instead, it's going to be a rectangle where everything is, I have the nice perpendicular lines. Just like that. Now, at this point, we need to draw in the diagonals of the rectangle. Make sure you do it dashed, because what these are, they are the slanted asymptote lines of the hyperbola. So once you have your slanted asymptote lines drawn in, then go up to V1, your first vertex right up here. This portion of the hyperbola opens up, and it's going to go all the way out to the asymptote line on both sides. Those asymptote lines are giving the shape of the hyperbola. Once you have the top one drawn, now go to the bottom vertex and do a similar one, but this time it's going upside down. And both sides of the hyperbola need to follow the asymptote lines going out. That's a hyperbola. Last thing we need to do is put in the focus points. So for the focus points on a hyperbola, c squared equals a squared plus b squared. So that is 9 plus 25. So c squared equals 34. C equals the square root of 34, which is approximately 5.8. From the center, we're going to go up 5.8 units. And that's focus 1. And from the center, we're going to go down 5.8 units for focus 2. Last one. This time we're going to graph the hyperbola x plus 1 squared over 9 minus y plus 2 squared over 17 equals 1. Notice the equations on the hyperbola, they both equal 1, but in between each fraction is a minus sign. All right, so this time, start with the center. Center, still hk. H is -1, k is -2. Look to see which variable comes first. Since x comes first, that means my transverse axis is x, and it's going to open left and right. All right, a squared always comes first. So a squared equals 9, meaning a equals 3. B squared equals 17, B equals the square root of 17, which for this, that means that is approximately 4.1. As we begin with the center, center is at -1, -2. From the center, we're going to go A units left and right because this one is opening left and right. So 3 units to the right, 3 units to the left. It is approximately 4.1 units up and down. Then draw the rectangle. Once you have the rectangle, draw in the slanted asymptote lines. Remember, these are the diagonals of the rectangle. Your vertices were to the left and right of the center, so there's vertex 1, here's vertex 2. Hyperbola, one side of it is going to open to the right following the asymptote lines. The other is going to open to the left following the asymptote lines. Last, for the focus, c squared equals a squared plus b squared. That is 9 plus 17. So c squared equals 26. C equals the square root of 26, which is approximately 5.1. So from the center, we go to the right 5.1 and to the left 5.1. That is how you graph hyperbolas. If you have any questions, make sure that you ask.